it's nothing crazy. It's just you have to come up with the equations first before you can solve them. The good news is, once you come up with your equations, you can solve them any way you want. All right. So for me, and again, this is like a gift, right, from me to you. It's not something that you're going to be able to do on the Regents. They will not accept this as an approach. But once you come up with your equations, because that's the unique skill, if you wanted to use the RRF technique to solve from there, you're welcome to do that. All right. There's no requirement that you do it algebraically or graphically. You just need to come up with the answers. All right. So on the test, I promise you, I will not give you a word problem and then write only an algebraic solution will be accepted or only a graphical solution will be accepted. It will be, give me the answer. Because the skill I'm looking for is whether you can define your variables appropriately and come up with the equations. And then, yes, I would also like the answer, but that's not as important. All right. So in number 2, Ava tells her little brother Tony that she is holding 20 coins, all of which are dimes and quarters. They have a value of $4.10. She says she will give them the coins if he could tell her how many of each she is holding. What would you tell Tony to help him solve this problem? Now, that's a Regent's way of asking the question. It's kind of frustrating because I would tell him, well, good luck, pal. You're probably not going to be able to guess it. So give up.
No.
Go get some ice cream. Yeah, like I would make it, something enticing for him. Like, okay, you're not going to win this battle, but let's go get a slice of pizza and some ice cream. All right. But the question really is saying, how many dimes and how many quarters is Ava holding? All right. So that's our let statement. So this is too thick. It's appealing, but it's going to take too much space. So let X equal number of dimes and Y equal a number of quarters. Now you can go with D and Q if you want. The only concern with that, and it's not a major concern, but the only reason I would probably steer away from that would be if I wanted to use a graphing approach, graphing calculator, or creating a graph on paper. I would rather have X's and Y's, because if I'm thinking of an X-intercept or a Y-intercept, it's a little bit clearer if there are X and Y values in there. All right. She's holding 20 coins. All right. Well, number of dimes, number of quarters have to add to equal 20. They have a value of $4.10. All right, well, what's the value of a dime? 10 cents. So 0.1, because we're working in dollars and cents, so 0.1x plus, well, then a quarter would be 0.25. Y. It is Friday, right? Oh, thank the maker. All right, 410. All right, so you have 4 strategies. You could graph it. You can substitute. You can eliminate. Or you could RF. All right. And again, I need to make sure I say this repeatedly. On the Regents exam, RF is not a thing. All right. I mean, you could use RF for multiple choice. If there's a multiple choice question, you can use RF. But they're not going to accept it for free response. All right. So I'm going to say that probably 1,000 times before the year's over. Right? Not even necessarily with just this topic. All the little calculator shortcuts and hacks that I teach you, anything that is allowable on the Regents, I'll make that clear. Whatever they're not going to allow, I'll also make that clear. All right, so decide on what method you want to use and then solve it. All right, so in this case, I'm thinking elimination. If we're gonna do it by hand, it's set up in standard form, X, Y, and then the constant. So I'm thinking elimination. Probably easiest to get rid of the x's. So what should I multiply my first equation by? Negative 0.1. So we're looking at, and I'll rewrite, negative 0.1 x minus 0.1 y equals negative, what's 10% of 20?
2.
2, so negative 2. And then 0.1x plus 0.25y equals 4.1. X's cancel. We're going to have a 0.15 y equals 2.1.
Yeah.
Now, we are talking about numbers of dimes and quarters, so if I get something that's not a whole number, I'm going to be a little concerned. Divide both sides by 0.15. What do I get?
5 was 14.
14. And so x would have to be what then?
6.
6. I mean, you can set up an equation to figure that out if you want, but if we know that they're going to total out to 20 coins and you got 14 of them as dimes, quarters, and the rest have to be dimes. All right? Word problems, so indicate what it is. I mean, you don't have to write a complete sentence. Like, Tony would have to, I mean, it implies that you should, but I don't have an attention span for that. So what would you say? Tony would have to guess that there are no, just 14 quarters and 6 dimes. Okay. Sneezing, but I enjoy that sort of stuff. So anyway, yeah, you got to be flexible. That's the whole thing. So when we're coming up with a graphical solution, you may not instinctively think to do this, but you're going to want to try to at least train yourself to sometimes think to do this. All right? And that is, instead of solving these equations for y in terms of x, why not graph them by intercepts? All right? Because the technique I showed you is just basically as simple as cover up the variable you don't want because you're replacing it with 0 and solve for the other one. So the x-intercept here would be x equals 2. All right? So x equals 2. I'll give it a little thickness. Cover up the x, y equals 2. Now all you need to plot a line are 2 points and a ruler. All right, so that's one of them. I'll label it up later. Cover up the x here. We got 2y equals 10, so y equals 5. Cover up the 2y. I got negative x equals 10, so x equals negative 10. So that's going to put us right here. 2 points and a ruler. You need your labels because you have more than one graph on the same set of axes. All right, so I have to take a couple of seconds and do that, but 2y minus x equals 10. X plus y equals 2. The solution is the intersection right here, negative 2, 4. All right. So now let's talk the algebraic approach. All right, so if you're so fixated on the substitution method, you're going to be spinning your wheels a lot. You're going to be spending a lot of time doing stuff that is really unnecessary, because if I just take a second and rewrite my two equations, x plus y equals 2, negative x plus 2y equals 10, it's already set up for elimination. The x's will cancel. I saw some people doing great stuff. And what they did was they said, oh, I'm not even going to rearrange it. I'm just going to add the x and negative x. Those will cancel. Y and 2y, that'll give me 3y. So 3y equals 12. Y equals 4. All right. So now I just grab what I consider to be the easier of the two equations. I think it's x plus y equals 2. So x plus 4 is equal to 2. So with explanation and color coding to some extent, I'm able to solve both touches on it just by indicating my final answer in the proper notation. Knowing that I did it correctly, Because I got the same answer that I got when I did it graphically.